Okay, I'm working out, but I stopped to do this because I thought it was neat and it was bothering me. So, we want to know if the sum from n to 1 to infinity of n factorial over n to the nth power converges or diverges. If you look at, term 1, 2, 3, 4, blah, 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 you'll see that they stop. They get to God, I don't even know, but they tend to plateau. So you've got a good guess it'll converge. So to prove that, we can do the ratio test. We can also do the comparison test, but I'm going to do the ratio test because I think it's neat what happens in the middle of it. So the ratio test, you take the limit as n approaches infinity of your sum of the sum a n plus 1 over sum with n, absolute value, and that'll give you something L. If L is less than 1, our series converges. If L is greater than 1, the series diverges. If L equals 1, then fuck, you have to do something else. You do comparison test or something else. So we'll do this and we'll see what happens. So the limit, if you can see that, limit of n to infinity, absolute value, a to the n plus, I'm out of breath, a to the n plus 1, so we'll take all these terms and add 1, just the way it is. It'll be n plus 1 factorial over n plus 1 n multiplied by the reciprocal of the original, and n over n factorial. So we can start canceling stuff out, rearranging terms, and trying to get something that's less messy to work with once you put in infinity. So right off the bat, we can cancel those because n plus 1, everything below that is just n factorial, so you can just cancel that out and leave the n plus 1. And then these, oh, big fuck, that's n plus 1. Fuck. There, so now we can make these both have n in the exponent, so we can rewrite this infinity. So these cancel, so you're left with an n plus 1 outside, and now we have an n to the n over. We can effectively take one of those out, and then we'll have an n plus 1 to the 1 power. We took out the 1, multiplied by n plus 1 to the n. So now we have interesting, and then we have interesting. So arrow, we can write that as the limit n to infinity. These turn into 1, so they don't really do anything. Interesting. And then we can put these at the same exponent. So it turns into an n over n plus 1 to the n. So far that seems kind of fucky still. Just a little bit. So, wait a minute, did I do that right? Yeah, that's right. Just making sure my algebra is good because the next part's kind of important. So then you can rewrite that again as the limit of n plus 1 over n. We're just flipping it, so now it's a negative n. And then we can rewrite the insides. Notice we have the n plus 1 up there. That's really neat. So it's n over n plus 1 over n. That's 1. So 1 plus 1 over n. That's real neat. So then we can rewrite the whole thing again. Limit as n approaches infinity, absolute value of, so the inside we rewrote as 1 plus 1 over n to the negative n. Looking familiar yet? Negative n, we can rewrite that as the limit as n approaches infinity, absolute value, 1 over 1 plus 1 over n to the n. Recall that the limit as n approaches infinity of 1 plus 1 over n to the n is e. So effectively, this goes to e, so it equals 1 over e, just like the limit of as n approaches infinity of 1 to the 1 over e. That's just a number, right? So this is a constant. So that equals L. 1 over e is about 1 over something like fucking 3.368, I want to say, which is L. So that means L is less than 1, so it converges by the ratio test. Sure does.